right? Okay, have you ever understand all above? Okay, so that's moving to the second part, is motion graph. And to describe what is a motion graph, we can just know these four diagrams as here A, figure B, to figure C, and figure D. There describes four states of the car motion. And the first diagram, it says that the car traveling at a steady speed. Second part is the car traveling at a higher steady speed. Third part is car accelerating, and the last part is car stopped. Okay, so let's looking at the first diagram. So here are three steps you must remember to just check what is the diagram meaning. Okay, the first step is that first to examine what is the y-axis and x-axis. Examine y-axis and x-axis. So here y-axis means the distance or meter, right? Distance taken. And the x-axis or x-coordinate means time per second, means the time, right? Y-axis means the time taken as s. So the second procedure or second process for us is to examine the slope for the graph. So if you have ever knew something or learned something about IG mathematics, you must know that gradient means in the diagram we have y equals to ax plus b, right? So a means the gradient, or you can just imagine you are in a mountain, whether the mountain is very steep or very flat. That means a slope of the mountain. Okay, so here slope, or you can also set gradient. Okay, slope and gradient in this diagram means y over x, right? So if you are in a mountain, imagine you're in a mountain, if there is x, so if you increases the y-axis, you can find here the slope is bigger than the first kind, right? Okay, bigger than the first kind. So here we use y over x to describe the slope. Okay, here is slope. And the third procedure or third process is to examine what is the area of the total diagram. Okay, so area means that the straight line, here is an area between the straight line and x-axis, and here is a perpendicular line from the edge of the straight line. So here you can find, we use the green lines to describe what is area. Here, we surrounded the gray area as a triangle, right? It's the area we want to solve about. Okay, so here area means that y times x. As you using the area formula for the triangle, the height times the y's times the half equals to the area of a triangle, right? So here we use y equals to x means the units of the area. So in here it's a distance and time diagram. We just have two procedure. It's just okay for us. Okay, let's find what is about this. So here you can find in this first diagram, here the distance is 40 meter per second. Oh, sorry. In just 4 seconds, it's 40 meter per second. Oh, sorry. Sorry. It's 40 meter for the distance in the first 4 seconds, right? So you can use the formula, the V equals to D over time taken. So here D over time taken is also the slope, or y over x, right? So here distance is 40 meter in just 4 seconds. So the velocity here is 10 meter per second, right? As you can also find here, in 4 seconds, it's traveling for 40 meters. So in this motion graph, you can find the velocity, find the distance traveling in the correct or in the constant time, right? Okay. So here you can find in the diagram B, here's a little bit difference between the diagram A. You can find the slope is steep than the diagram A, and you can also use the 2 steps to just look through or understand the diagram, right? First step, we find the x-axis and y-axis, or units of x-axis and y-axis. Here is time and distance. So here, the slope of the diagram is y over x, which means meter per second. Okay, so here you can find it means the slope or also means velocity. So velocity here is 100 meter per 5 seconds. Okay, so here equals to 20 meter per second, right? So here we have the velocity right here. Okay, and we can just see through the diagram. It has a bigger velocity than the first diagram A, right? Okay, so let's keep on moving to the diagram C and diagram D. In the diagram C, it means that car accelerating. So we just imagine you're a mountain as you just climbing forward to the top or to the crest of the mountain. You can find there's step by step. Yes, here you can see the mountain is a little bit flat, and here the mountain is a little bit steep. So it's very hard for you can maybe have to exert more energy to climb the mountain, right? Okay, so velocity equals to y over x, or it's a slope. It's increasing all the time. So here we can determine that the car is accelerating all of the time. Okay, so at last diagram, it's very easy for you to understand it. The distance of the car just stays still at 3 units every time. So here you can find distance equals to 50 meter. So which means that the car stays still or the car stopped. Okay, so here are the four basic diagrams or four basic analysis for the speed, for the distance time graph, and we know that the slope, it means that the velocity. Okay, so let's move into E part and F part. So in the E part, car with steady speed. So here you can find here, it's a speed and time graph, right? So we also use our 3 steps. The first step is to find y-axis and x-axis. The second part is to find the distance or the slope, right? The slope. Here, the third procedure is to find the area for the total diagram. So here we knew that slope means y over x. In this diagram, y over x means meter per second over second, as we know that equals to meter per second square. And we just tell on the other slides, like here, we knew that acceleration is final velocity minus the initial velocity over the time taken. And here, the velocity changes in per second is unit, which means acceleration is a unit is meter per second square. Okay, so here we knew that is the acceleration. So just imagine you are in a mountain. You can find here. So it's just a flat mountain, which means the slope equals to 0, or there's no slope, right? So here you can set y over x equals to 0, or slope equals to 0, or acceleration equals to 0, right? So as a third procedure or third process to find area. So here area, we knew that it's a straight line, and with an x-axis and at the edge, we have to draw a perpendicular line here. So this area is called the rectangle, right? Okay, so here we can use a formula for rectangle area. Is height times width. So here is 15 meter per second times 5 seconds. So we can easily find here the unit is second, and here is 75 meter. So in the speed and time graph is like a time. So its area is for just the distance moving. Okay, so let's moving directly to the diagram F. And here you can also use 3 process. The first process is to find y-axis and x-axis. So here is meter per second speed, and second is time. Second procedure is to find slope y over x. So here y over x is meter per second square over the second. Oh, sorry, meter over second over second. So equals to meter over second square. It's over 2 times of second. So we use meter over second square. Okay, so this is a unit of acceleration. So in the diagram, you can find here the acceleration maybe equals to 20 over 5 equals to 4 meter per second square. So this is the car with a steady acceleration, right? And here you can also use a three-step. The third step is find the area for the total diagram, the straight line and the x-axis and the perpendicular line at the edge. So here, we just find this rectangle's area. Also using the rectangle's formula, a half times the height times the width is a half times 5 seconds times 20 meters per second. So the final answer here is about 15 meters. So we knew that the car has traveling for 15 meters in the 5 seconds or in the first 5 seconds, right? Okay, so here you can find there are more information in the speed and time graph than in the distance and time graph. In the distance and time graph, we can only find maybe for slope and for the y-axis, it's about speed and distance, right? And in the speed and time diagram, we can find three like characteristic of the motion. The first is velocity. It's just what y-axis means or what y-axis tells us. And the second properties or second parameters is the acceleration, which means the slope parameters is area, which means the distance moving. Okay.